Hey there, as promised, here comes a video about factoring trinomials, and we're going to look at two different types. One type where we say that a is equal to 1. You might say, well, where is a coming from? I thought these were all x's. Because when we write a trinomial, we're talking x squared, so we say ax squared plus bx plus c, where a, b, and c are actually numbers, coefficients, and a constant. All right, so that's where when I say a equals 1, so that's why these are going to there's not going to be a number in front of x squared. So to help us with this, and because I have told you, right, repeatedly I've mentioned that factoring can be checked with multiplication. They are like inverse operations. And so let's review a little bit about multiplying binomials. So binomial, when we have two sets of parentheses, and we can do that with that whole FOIL process, which is the first terms, the outside, insides, and last times last. That's what, when we say FOIL, or FOIL it out, that's what we're talking about. It's just an acronym, all right? So, and this is an I, and this is an L. There we go. So, that will only work when it's a binomial times a binomial. So I usually just think about distribution and distributing and starting at the left and distributing. Now, I want you to see something though. If these are just x's at the front or whatever variable, then we can even take a shorter route than that. So I'm going to multiply this out the long way, and then I'm going to tell you or remind you about the short way. So if I multiply it out the long way, the first one times the first one, the x times the x would be x squared. The outside times the outside would be 2x. And then inside would be the 4 times x. And then last times last would be 4 times 2, would be 8. And then the 2 in the middle, we would combine like terms. And this would become x squared plus 6x plus 8. And notice it is a trinomial. It has 3 parts after I multiply. All right, so now let's think about if there's kind of a shorter way that we could have gotten that answer. Not that there's anything wrong with that way, but if we know this shorter way, it's going to make factoring these trinomials a lot simpler. This is going to make a lot more sense to us. So when I have my x plus 4 and my x plus 2, I think we can all agree when I look at this that I know it's going to end up having an x squared, right? Now what ended up happening there in the middle? The 2x and the 4x got added together. So let's just look at this 4 and 2, take those two numbers and add them together. And the middle always gets an x because it starts out x squared and then some x's, and then last is going to be just a number. So to get that number, I'm going to do 4 times 2. So notice what we did. We add to get the middle, and we multiply to get the end. So when I'm looking at these binomials, instead of doing the whole FOIL process and needing to combine like terms, I can use this shortcut. So x minus 5 times x plus 4, I know is going to be x squared. Now I'm going to add negative 5 and 4 together. That gives me negative 1, so negative x. And then I'm going to multiply negative 5 and 4 together. That gives me negative 20. So I added the two constants together to get the middle, and it always gets an x. I multiply it together to get the end. So x times x, x squared, negative 2 plus 8, positive 6, always gets an x, and then negative 2 times 8, multiply, is negative 16. The signs are going to be important, so pay close attention to those. And then my last example there, x minus 4, x minus 9, so x squared, negative 4 plus negative 9, negative 13x, negative 4 times negative 9, plus 36. So those are some examples where we're multiplying, okay? Now, what we're going to do now is we're going to go backwards. We're going to factor. And so, since when we were multiplying, when we thought about the shortcut, we added to get the middle and we multiplied to get the end. Now, there are infinite possibilities that could add up to get something. But there are not that many different factor pairs that can multiply to get a certain number. Not if we limit ourselves to whole numbers. So we will be thinking about what multiplies to be the last number, but adds up to be the middle number. And our answers will look like these 4 example problems did. Ready? Okay. So again, we're going to look for what multiplies to be the last number, what multiplies to be the constant, and adds up to be the middle. So again, this is in your notes. This is in your notes on page 15. And notice it even reminds us here we are finding the 2 integers that multiply to be C and add up to be B. C being the constant, B being the middle. And sometimes you may see me draw this little organizer, and you may, if you're watching in Miss Miriam's videos, you may hear her call this the X factoring. There's nothing magical about this X. We will use a modified X and make it an asterisk for something else, but it's just a way to organize what we're doing, that we multiply to get 12 and we add up to get 7. Now, I personally don't usually use that, but just kind of putting it out there because it might help you. But I know that this is going to be 2 sets of parentheses. I know they both need an x to get x squared. Now, my next thought is going to be what multiplies to be a positive 12. Okay, it's a positive 12, so I know the signs are the same. So if this is positive, same signs. If it's negative, the signs are different. Because remember, when you multiply and they're different, you get a negative number. So this is positive, so the signs are the same, and then I need to look back here to see what the sign is. So this is it also adds up to a positive, so they're both plus. So now what multiplies to 12 and adds up to 7? So my choices that multiply to 12, 1 times 12, 2 times 6, 3 times 4. And this is where you could use that second page in your packet, and I told you to take that page off. That second page of your factor packet where I gave you a reference page that had factor pairs. So you could look up 12 and it would give you these 3 pairs. Most of you could come up with this without that help, but just in case. So 3 and 4. 3 and 4. They're both plus, so it doesn't matter which one I put where. And then I can check it with the shortcut. When I add them together, do I get the middle? When I multiply them together, do I get the end? I do. Okay, so let's go over here to number 2. This time we switched it up and used n. So I'll make sure I write n. I see it's a positive 20, so the signs are the same. I look at the middle, they're both going to be positive. Okay, so they're both positive because this tells me they have to be the same. And if they're the same and they add up to a positive, they must both be positive. So what multiplies to 20 and adds up to 9? So 1 and 20, that adds up to 21. 2 times 10, that adds up to 12. 3 doesn't go into 20. 4 times 5, yes, good job, 4 times 5. And again, we check it by making sure they add up to be the middle and multiply to be the end. So here, notice also, guys, I am not thinking about what adds up to be the middle first. I'm thinking about things that multiply to be the end. So what multiplies to be 18, but adds up to be 9? 1 and 18, doesn't add up to 9. 2 times 9, that adds up to 11. Does 3 go into 18? 3 times 6. And does that add up to 9? Ding, ding, ding. Winner, winner, chicken dinner. So h plus 3 and h plus 6. Hopefully, starting to click a little bit. Go ahead and try 4, 5, and 6, and when you come back, I'll have answers there. Nothing tricky about these. They are both positive in your factors. Okay, so I hope that you paused me and you took a chance to try to work those out yourself, because now they're magically there. So for number 4, I got a plus 4, a plus 6. And I can check that. 4 plus 6 gives me the 10. 4 times 6 gives me 24. For number 5, k plus 5 and k plus 1. It doesn't matter if you put the 5 in the first one or the 5 in the second one, but it is 5 and 1. If you put 2 and 3, you have things backwards. It's not multiplying to be 6. This is multiplying to be 5 and adding up to 6. And then number 6, the only thing we can multiply to get 1 is 1 times 1. So since they are both the same, y plus 1, it could be written with one set of parentheses with a second power on the outside. That would mean the same thing. Okay, so I'm going to go down to the next part of the page. We're going to have some where they're not both positives. And that's where things start to get a little trickier because we have to pay closer attention to the signs. All right, so I not only scrolled down, but I added a couple problems that you can put at the bottom of your page. So on number 7, now when I look at that 18, it is a negative 18. So if you feel like you like this little X to help you organize, I would, when I have a negative on top, one of these is going to be plus and one of them is going to be minus. Because to multiply to get a negative, the signs have to be different. And what happens when we add things with different signs? Well, when we add things with different signs, we really end up subtracting the number parts, right? So remember, same signs add, opposite signs subtract, bigger number wins. So when I am thinking of my factors now, I'm looking for two things that multiply to be 18. I know it's one positive and one negative. Because their signs are different, they subtract to make 3. So 1 times 18, but that would subtract to be 17. 2 times 9, that would subtract to be 7, 9 and 2. 3 and 6. So I'm going through my different options. 1 and 18, with one of them being negative and one of them being positive. 2 and 9. 3 and 6. And then for the sign, since the sign of the middle number is a positive, the bigger number needs to go with the plus sign. So when they're different, we know which one goes with the plus or the minus because the bigger number has to match the middle. That way when I add them together, remember that shortcut, when I add them together to check my answer, 6 and negative 3 makes positive 3. 6 times negative 3, negative 18. So similar situation on number 8, 2 sets of parentheses. I see that 8 at the end is negative, so I know there's one of each sign. What multiplies to be 8, and if I subtract, I get 2. So the only things that multiply to be 8 are 1 and 8 and 2 and 4. Sorry about my interruption there. So this would be a positive 4 and a negative 2. And I will probably also give you guys a link to when I taught this in Algebra 1 because I had a lot more practice problems. But because the assumption is that you would have already done it, I don't include as many practice problems for the Algebra 2 class. So let's look at some of these down here at the bottom that I added in. If there is a plus at the end, the signs have to be the same. But if two things multiply to give me a positive, they have to have the same sign. But if they're adding up to be a negative, that means those both must be negative. So what would multiply to be 12, but add up to be 8? 6 and 2, but they're both negative. So same kind of thing over here. So when you see a negative and a positive in this order, that does not mean one of each. The last sign is positive, the signs must be the same. So in this case, what multiplies to be 20 and adds up to be 9, and negative 9 would be negative 4 and negative 5. One more example here. It's going to be very much like number 8. What if instead that said minus 2x minus 8? It does not mean there's two minuses. That would be signs are the same. The last part would have to be positive. This kind of problem still means there's one of each, but now it means that the negative number is bigger. This would be negative 4 and positive 2. And so those are trinomials with a equal to 1, or you might see it called trinomials with no leading coefficient. In other words, there's no number in front of the squared term. And so that's going to be really important that we know how to factor those because we're going to see lots and lots of problems where we have to factor those.